Hey achievers, welcome to the physics session in the Scholar. In this session, we learn about force. The first half of the session for force consists of the definition of force and the types of forces, wherein the second half is completely dumped with shortcut formulae that can be used in the numericals being asked in IIT and NEET entrance examinations. Here we go. Let us start with the definition of rest. An object that does not change its position with time is said to be at rest. An object that changes its position with time is said to be in motion. Momentum is the product of mass and velocity of a body given by P is equal to mv. Force is an action that changes or tries to change the state of rest of a body. From Newton's second law, the rate of change of momentum is called force. Coming to its mathematical expression, force is equal to change in momentum by time. F is equal to mv minus mu by t. Otherwise, F is equal to ma, where a is acceleration and is given by v minus u by t. The units of force in CGS system is dyne, and in SI system it is Newton. The relation between dyne and Newton is 1 Newton is equal to 10 power 5 dyne. Force can perfectly be represented by four components. 1. The nature. 2. The magnitude. 3. The direction. And 4. Point of application. First, coming to the nature. By nature, force can be a push or pull. Magnitude. It is the amount of force applied on a body. Direction. Force on a body can either be applied on horizontal plane or vertical plane. This is the direction of the force. Next, point of application. It is the point where force is applied. Let us learn about all the four components of the force with an example. This is a push of 10 Newton along horizontal direction at point A. Let us see another example. This is a pull of 20 Newton along vertical direction at point P. Force is a vector quantity as it has both magnitude and direction. The basic forces in nature are three, and they are gravity, electromagnetic force, and nuclear force. First, coming to gravity. The force that attracts a body towards any other physical body having mass is called gravity. The second one, electromagnetic force. This includes basic electric and magnetic interactions and is responsible for the binding of atoms and structure of solids. The third one, nuclear force. The force that acts between hadrons. Hadron is a subatomic particle that are built from quarks, which are the elementary particles and is the constituent of matter. Forces can be divided into two types depending on the contact with the body on which force is applied. They are the first one, contact forces. Force applied on an object in contact with each other is called contact force. All mechanical forces are contact forces. Example, muscular force, frictional force, etc. Non-contact forces. Force applied without physical contact is non-contact force. Example for this is magnetic force and electrostatic force. Other types of forces depending on their action are applied force. It is the force applied on a person or object. Normal force. It is the force acting perpendicular to the surface. Frictional force. It is the force that opposes the motion of a body over another when the surfaces are in contact. Tension force. Force applied by a fully stretched cable or wire. Spring force. Force exerted by compressed or stretched spring. Air resistance force. The frictional force exerted by a body while moving through the air is called air resistance force. Now, let us move on to a concept called resultant force. The total force acting on an object is called resultant force. Let us learn it clearly with an example. In this example, a force of 10 Newton and 5 Newton are acting on the body along same direction. So the resultant force is the sum of the two forces, 10 Newton and 5 Newton, which is 15 Newton. Let us look into another example. In this example, a force of 20 Newton and 7 Newton are acting in opposite direction. So the resultant force is 20 minus 7, that is 13 Newton. Now when two forces act at some angle, the resultant force is given by the parallelogram law of vectors as R is equal to root of p square plus q square plus 2pq cos theta, where P and Q are the forces being acted at an angle theta. The angle of the resultant force is given by tan alpha is equal to Q sin theta by P plus Q cos theta. Now let us learn some formulae on force which can be directly applied in the numericals. When two bodies are in contact with each other as shown in the figure, the acceleration of both the blocks is given as A is equal to F by m1 plus m2. If F is the contact force between m2 and m1, then it is m2F by m1 plus m2. If applied force acts on m2, then it is m1F by m1 plus m2. The next condition. When three bodies are in contact with each other as shown in this figure, the common acceleration A comes out as F by m1 plus m2 plus m3. If F is the contact force between m2 and m1, then F is equal to m2 plus m3 into F by m1 plus m2 plus m3. If F dash is the contact force between m2 and m3, then it is given by m3F by m1 plus m2 plus m3. Now let us look into a condition of connecting bodies. If two bodies of masses m1 and m2 are connected by a slight string and lying on a smooth horizontal plane as in this picture, and m2 is pulled forward by a force F, then the common acceleration A is F by m1 plus m2. Tension T is m1F by m1 plus m2. Let us look into another case. If three blocks of masses m1, m2 and m3 are connected by light string and lying on a smooth horizontal surface, and m3 is pulled forward by a force F, the common acceleration A is given by F by m1 plus m2 plus m3. Tension T1 becomes m1F by m1 plus m2 plus m3. Tension T2 becomes m1 plus m2 into F by m1 plus m2 plus m3. Now, let's move on to the motion of bodies connected by string passing over a pulley. Let a block of mass m1 tied to another block of mass m2 by light string passing over a pulley. m2 is hanging freely and m1 is on the horizontal surface. In this case, the acceleration of the system A is equal to m2g by m1 plus m2. Tension T is equal to m1 m2 into g by m1 plus m2, and thrust on the pulley is square root of 2t. Let us study the another case wherein three bodies of masses m1, m2 and m3 are connected by a pulley like this. In this condition, the acceleration of the system A is equal to mg by m1 plus m2 plus m3 plus m, where capital M is the mass down the pulley. Tension T1 is equal to m1 into mg by m1 plus m2 plus m3 plus capital M. Tension T2 is given by m1 plus m2 into capital Mg by m1 plus m2 plus m3 plus capital M. Finally, the tension T3 is given by m1 plus m2 plus m3 into capital Mg by m1 plus m2 plus m3 plus capital M. Let us move on to another case wherein two bodies m1 and m2 are connected by a two-pulley system through a body of mass capital M. In this condition, the acceleration of system A is equal to m1 minus m2 into g by M1 plus M2 plus capital M. Tension T1 is given by M1G into 2M2 plus capital M by M1 plus M2 plus capital M, and tension T2 is given by M2G into 2M2 plus capital M by M1 plus M2 plus capital M. The concept of force is not yet completed. There are many more formulae to be learned. We'll continue the concept on force in our next video. Bye-bye. Dear achievers, welcome to chemistry session. In this session, let us learn about the atom and its structure. Let me start with the definition of atom. Atom is the basic particle of the chemical elements. An atomic structure is the constitution of its nucleus and the arrangement of the electrons around it. Atom has three fundamental particles. They are proton, electron and neutron. The three fundamental particles in an atom can be easily remembered with a mnemonic pen, where P stands for proton, E stands for electron and N stands for neutron. Protons and neutrons are in the center of the atom, making up the nucleus, and electrons surround the nucleus. Now let us learn about the masses and charges of proton, electron and the neutron. First, coming to the proton. Proton is a positively charged particle with the mass 1.672 into 10 power minus 24 gram or 1.672 into 10 power minus 27 kg. It has a positive charge of 1.602 into 10 power minus 19 coulombs. Coming to the electron, it has a mass of 9.108 into 10 power minus 28 gram or 10 power minus 31 kg with a charge of 1.602 into 10 power minus 19 coulombs of negative charge. Moving on to the neutron. Neutron has a mass 1.674 into 10 power minus 24 gram or 10 power minus 27 kg, and neutron is neutral. Now, I have a question for you children. Why the atom is electrically neutral? Here comes the answer. In an atom, the number of protons and the number of electrons are same, or the amount of positive charge on protons is equal to the amount of negative charge on electrons. Thus, the atom is electrically neutral. Now, let us move on to another interesting topic. Can atom be created? Yes, atoms can be created. You just consider nuclear reactions like nuclear fission and nuclear fusion. In these reactions, atoms can be created. For example, nuclear fission is a reaction where a heavy nucleus is converted to lighter nuclei. Here in the given example, uranium, a heavy nucleus, is being changed to barium and krypton. So here, from uranium, barium and krypton have been created. Thus, we can conclude that atoms can be created. One more question for you children. Can atom be destroyed? Again, it's a yes. According to law of conservation of mass and energy, atoms can be destroyed. One more question for you. What is the condition for stability of atom? The answer is, atom has nucleus at its center and electrons revolving around the nucleus. If plus E is the charge of nucleus and minus E the charge of electrons, which are separated by a distance r, then the electrostatic force of attraction between them is given by F is equal to minus E square by r square. And when these electrons keep revolving around the nucleus, the centrifugal force developed due to rotation of electron is given by F is equal to minus mv squared by r. As long as these two forces are equal, the atom remains stable. Now, in the first statement I had given in the introduction, I referred that atom is the basic particle of the chemical elements. Now, let me tell you what an element is. An element is a substance made up of only one type of atoms. An element is represented by XZA, where X is the name of the element, Z is its atomic number, otherwise called number of protons, otherwise called number of electrons, and A is called its mass number or number of nucleons or atomic weight. The value of A minus Z gives the number of neutrons. Let us take an example to learn it further. Here we took an element called nitrogen whose atomic number is 7, which means it has 7 protons and 7 electrons. Its mass number is 14. Otherwise, its atomic weight also can be considered as 14, and it has 14 nucleons in it. Coming to the calculation of number of neutrons, just subtract A minus Z, that is 14 minus 7, which comes to 7. So it has 7 neutrons in it. Now, let us move on to an interesting topic wherein we can learn about some topics like isotopes, isobars, isotones, isotopic number, isodiaphers, and isosters. I start with isotopes. So atoms of the same element with the same atomic number but different mass numbers are called isotopes. Isobars. Atoms of different elements with different atomic numbers but same mass number are called isobars. Next, isotones. Atoms of different elements with different atomic numbers and mass numbers but with the same number of neutrons are called isotones. Next, isotopic number. The value of A minus 2Z or the value of N minus Z is called isotopic number. Let us take an example and learn this. Here we took an element 8O18. You can observe that the mass number is 18 and the atomic number is 8. Let us find out the value of A minus 2Z. A is 18 and Z is 8. Now 18 minus 2 into 8 becomes A minus 2Z, which comes out to 18 minus 16, that is equal to 2. Now let us learn about isodiaphers. The elements with same isotopic number are called isodiaphers. Here we have an example 6C14 and 8O18 whose isotopic numbers are 2. Next, isosters. Molecules with same number of atoms and same number of electrons are called isosters. The example we took here is nitrous oxide N2O and carbon dioxide CO2. If we observe, N2O and CO2 have 3 atoms each and they have 22 electrons each. Since they have same number of atoms and same number of electrons in them, these are called as isosters. Now let us learn what an atomic model is. The arrangement of fundamental particles in an atom is called atomic model. The first model of atom was put forward by J.J. Thomson and it is called as watermelon model. According to J.J. Thomson's atomic model, an atom consists of a positively charged sphere with electrons embedded in it, like the seeds in a watermelon. The seeds in the watermelon are compared to the negative charged particles and the red part in the watermelon is compared to the positive charge. The limitations of this theory is it could not explain the stability of atom or it does not have any experimental evidence. The next model of atom was proposed by Rutherford based on alpha ray scattering experiment. The alpha ray scattering experiment comes out like this. In Rutherford's alpha ray scattering experiment, the high energy stream of alpha particles are bombarded to a thin sheet of gold of 100 nanometer thickness. These rays are then incident on a fluorescent zinc sulfide screen causing scintillations. From the experiment, following were the observations. The first one, most part of the atom is vacant, thus alpha particles travel in a straight line and cause scintillations on the screen. The next observation is the mass of the entire atom is concentrated at the center of the nucleus. Thus, when these alpha particles come closer to the nucleus, they are deflecting with some angle. With the observations in the alpha ray scattering experiment, Rutherford concluded that the mass of the entire atom is concentrated at the center. Around the positively charged nucleus, the negatively charged electrons, just like the planets revolve around the sun in the solar system. Thus, Rutherford's model is also called as planetary model of atom. The electrons and the nucleus are held up by strong electrostatic force of attraction. The limitations of this are Maxwell's electromagnetic wave theory explains that accelerated charged particles like electrons emit radiations. If Electrons emit radiations, they will lose energy and leads to the shrinking of orbits, thereby leading to the instability of atom, which was not properly explained by Rutherford. That was the chemistry session of the day. We'll continue with more interesting topics in the next session. Celebrate the learning of life. Take care. Bye bye.